as usual, we'll kind of start off with just a few announcements and things. Anybody have any announcements or you want to mention? We need to, let's see, are there anything to say about relocation or any of that sort of thing?
Me and Gary put in step one grant part. Basically a quick description of what we are asking for on the Roses 2025 York, which is a planetary defense grant for NASA. So maybe we'll hear from them soon. I could log in and check, see if any update has happened. I haven't gotten any notices or anything. But we should probably hear soon and go for the next phase. Actually, we probably won't hear anything till the end of phase one, which is like September 12th or something. So.
Well, that's good. I know, one of the things that's been hugely concerning to us is that NASA's thinking about cutting out all Earth science, which is a looming prospect, but maybe they'll have a little bit of silver lining. Maybe there'll be a little bit more money available for things like military defense. To me, that's a difficult trade-off to think about, but let's keep our fingers crossed.
I've heard that 1.7 million was allocated for the planetary defense in this grant.
Yeah.
That's downsizing what it used to be, and you got people like Kelly, Professor Ray, that go a pretty good chunk of that.
Yeah.
So we'll hope for it. But,
$1.7 million sounds like a lot of money.
It's really
It's kind of a sad commentary on the times, but boy, it really is. Anything else? Any other love announcements? Anything anybody wants to throw out? We have, let's see, we've got public night scheduled for September 13th. That's a week from Saturday, right? Or is it the week after that?
We can do that.
Okay. So that one will be scheduled. Next general meeting is September 25th, and we will have a guest speaker that night. One of the things I meant to do is check on the name of this person who I didn't get a chance to. He is lives near Wichita, has a Goddard, and has an observatory where he does programs mainly in variable star observation. I sort of met him indirectly on a AADSO webinar. I saw his name on there, so I just shot him an email and kind of introduced myself. And he has agreed to give us a talk. That, I believe, will be remotely done. I think he's in a situation where he can't be around people for a while, so he will give a remote presentation. That will be next September. In October, Graham Bell will give a presentation, so 2 full months of not having to listen to me coming up. Anybody that wants to take a shot after that? I mean, like I said, I'm always looking for people who want to throw something out there. So if you feel like you might want to give a presentation on something, let me know. Shoot me an email. We kind of already communicated. So if you would do November, right? Okay. Okay, good. I thought there was another one there, but good. So we'll be booked up all the way through January, since there's no December. Okay. Anything else? All right. I did want to make one presentation or one announcement. This came by NSRAL, the kind of Midwestern Astro League club, and the same Saturday as our public night, September 13th. They're Olivet, Missouri, which is suburb of St. Louis. Actually, it's one of the western side. It's one of the suburbs on the western side of St. Louis. I guess this thing has been going on for a few years now, ever since James. Is his name James Dobson? Anyway, the fellow that invented the Dobsonian telescope passed away a few years back, and they held these Dobson fests, I guess, in his honor. So, if you have any interest in that, might be something worth checking out. Interestingly enough, all of that is or the park that they're going to hold this in is an urban dark sky site, which I didn't even know existed. When I was kind of looking at this just to sort of see what it was all about, they mentioned it, and that kind of got me down a little bit of a rabbit hole on what urban dark sky sites are. Apparently, there are such a thing, and this place is one of them. It's kind of a large extent of, I think there's a lake there that I actually rode on once in a rowing competition, based on the sounds of it. But anyway, it's this relatively large park with not many lights in it. It's got tree barriers around it and stuff, and it keeps it relatively dark. So, speaking of relatively dark, by the way, it sounds like we had at least some positive response from the school about the light on the flagpole. Was that correct?
The football flagpole, yes.
Yeah. So they've turned off the light that points up at the sky from at the base of the flagpole.
Yes.
Okay. That's good. That was one of the lights. Unfortunately, when they built the athletic fields out there, they lighted them quite well, and we've had problems with that ever since, which is one of the things that kind of motivated the attempts to move the Tomahawk. But the one light in particular that was the one that pointed up, right, is at the base of the flagpole and pointed up.
It's the north side of the football field, so that's very close to us. So
It's right in our line of sight for pretty much anything that's off to our south, which is where we point most of the time. So, I guess it's considered to be proper if you have a flag flying at night to have it illuminated. So in that respect, it's understandable. The problem is it was on even when there was no flag flying most of the time. So anyway, but it sounds like we've got at least some positive response on that. So thanks, Russ, for contacting them, and we'll hope that that'll help us out at least a little bit. I know we probably haven't had a good sky for checking it out since this happened, but we'll see.
since they have their football game, probably not be back on. So.
Well, yeah. Maybe, if we just sort of nudge them and say, hey, remember when, but yeah. I'm sure when there's football going on out there, it's lights everywhere, right? Because they have to turn on the lights on the field.
Well, right, the flagpole lights.
The flagpole
get
lights part of that.
on after they're done, so.
Well, this may be something we have to kind of continue to sort of play. But I was quite pleased to see that we got at least some response that was not, no. So I was happy to see that.
Oh, yeah, I originally thought it was intentional, just to always have it on all the time.
I was wondering that myself.
So if you see it on again, I'll probably, I could kind of check with the cameras that are out there, but if you notice it on, maybe just keep on asking to turn it off.
All right, anything else?
That park is in the middle of St. Louis.
It's kind of western edge though, right? Or is it totally
Yeah, it looks like in the middle of St. Louis to me, but
really? Yeah. Well, it's this big, relatively big urban area. But yeah, I was really pretty surprised. Apparently, it's not a bad place to look at the sky, which I'm sure it's not the same as being out in the country, but I was still quite impressed with that.
But your factory's in the middle of something or monsoon,
Yeah, I have some friends that live in the Phoenix area. You really see what happened there.
Florida was horrible.
Oh my gosh, that was amazing. They have this type of storm called which is a kind of a rotating wind. It's a horizontal rotating wind. It's actually a really interesting thing because you can use it as a visual representation for the kind of vorticity that if things continue a little bit more, it's flipped up on its end. east end of the valley, you know, and man, they started dusting. It was pretty incredible. Okay, anything else? Well, one of the things I haven't done lately, which I thought I might get back to, is talking a little bit about something in the sky. And I always try to come up with something that's at least seasonally appropriate. So I was trying to find a constellation that would be a sort of a late summer constellation that I haven't talked about yet. And this is the one I came up with, Capricornus Procedure. And, you know, like a lot of these things, when I start kind of digging into the story a little bit, it turns out to be a little bit more interesting than I would have thought, right? And this one was no exception. Capricornus is a relatively dim constellation, right? It's made up of some stars that aren't particularly bright. It is one of the zodiacal constellations, and actually that leads to a little bit of an issue with its name, because most of the time people say Capricorn, right? Well, it turns out that the constellation is called Capricornus, but the zodiacal sign is Capricorn. So I, you know, in solidarity with astronomy rather than astrology, I decided to stick with Capricornus as its name. But it is one of the zodiacal constellations, which of course are the ones that lie along the plane of the ecliptic, right? The projection of the plane of the ecliptic out into the sky. So it's one of the ones that planets travel through, right? Finding it is, honestly, I've never found it. I don't know if I've ever looked at it in my life. So I had to go, you know, normally I come up with how I would find it. In my case, I don't know how I would find it because I've never actually looked at it, at least not intentionally. But apparently it's not all that hard to find, despite being rather dim. It's kind of looks like a little bit of a squashed triangle or a little cap, you know, that's been squashed a little bit. Apparently the best way to find it is to find the summer triangle, which is typically pretty easy to find, right? And then if you use Vega, which should be one of the brighter stars in the summer sky, and Altair, Sphinx, it sort of points right at it, right? So you can kind of deflect your gaze a little bit, and you end up looking at Capricorn. By the way, it's depicted a couple of different ways, too. That's another thing I kind of noticed. A lot of times you see it this way, with this sort of squash triangle or caved-in triangle a little bit. But if you look at it on some of the planetarium programs, it shows it in connected dots connected together in a somewhat different way. It actually ends up looking kind of like that. The other thing I thought was really pretty interesting, so there it is kind of as in the sky chart version. You can see the ecliptic kind of running through there. Here it is in a, this is from whatever the free, Stellarium. This is what it looks like according to Stellarium. One of the things I never realized about Capricornus as well is that I always thought of it as a goat, right? It's actually a sea goat. It's partially goat and partially fish. And the reason why, at least in its depiction in mythology, and that was actually one of the things that sort of got me looking at what its story is. And as with a lot of these things, it kind of ties into, you know, mythology, basically. It's mythologically a pretty old constellation, actually. But when you look at the myth, at least in the kind of Greek and Roman mythological tradition, it actually relates, the story actually relates to the war between the Titans, who were a sort of mythological group that preceded the Olympian gods, right? You think about Zeus and all that as the Olympian gods. There's this pantheon before that, the Titans. The Titans and the gods had a battle, a war between them called the Titan Nakami, which was the war between the Titans and the Olympian gods. Won by the Olympian gods, so they were able to dispel the Titans, at least in most versions. One of the other things I always find about mythology is that there's always more than one story, and in many cases, variations on them as well. So this book of mythology that I've carried around with me since I was in college gets into this a little bit. This particular one I didn't talk too much about, so I kind of moved the internet source. Apparently there was this battle consequences of that was that the Uranus was the, in this mythology, Uranus was the, essentially king of the universe in this mythology. The Titans were his cohort. His wife was Gaia, who is also kind of one of the earth, kind of this earth goddess, right? And it's tempting sometimes to think from, you know, popular depictions of earth goddesses that Gaia would be sort of a nurturing figure, I guess you'd say. Not so much, as it turns out. Gaia was the wife of Uranus. They were not a happy couple. Again, as with most aspects of mythology, there's a lot of dysfunction in all this, right? This was a very dysfunctional marriage to the point where prior to the Titanomachy, Gaia actually tried to get one of the Titans to castrate Uranus. So he was, they were not a happy couple. Anyway, after this was all over, she was considered the mother of the Titans, basically. After the whole war was all over, Titans lost. Gaia was not too happy about that. She was quite displeased at being rather, I don't know exactly the word used, nasty character, testy character, vengeful character. She created a monster. Whose job it was to take out the Olympian gods. And this monster was called Typhon. Typhon was considered the ultimate monster. Anybody ever read H.P. Lovecraft? Was an American writer that wrote these creepy horror stories. It's thought that Typhon might have been one of Lovecraft's inspirations for Cthulhu. Their god of this horrible creature is the Lovecraftian evil god. Anyway, Typhon was this ultimate monster. Was supposed to be able to defeat the Titans. Did a pretty good job at it, actually. Attacked and was basically kind of kicking some Olympian god rear end. And ultimately what ended up happening was it came down to a final confrontation between Typhon and Zeus. And Zeus won, but it was not, it was almost like, it sounded almost like you ever see the original Rocky movie, or maybe it was the second one where, you know, after just getting these, you know, wailed on for round after round, it was this miracle finish, and Zeus was able to defeat Typhon. But the reason, where the whole Capricornus thing comes into play was that one of the Olympian gods was Pan, right? Kind of famous, I guess, for kind of one of the gods of the harvest, I guess, but also famous for the flute, right? The Pan flute. It's sort of this man-goat kind of amalgamation. Pan, essentially, in two versions of the story. One a little more friendly to Pan, where Pan is the one that actually helped Zeus get back into the fight. Basically, that's one version. The other version, which seemed to be a little bit more common, was Pan was running for his life, which after being pursued by Typhus, so there's a bas relief that kind of shows this. There's the Typhon, they're pursuing Pan. Pan is bugging out, trying to run away as fast as he can, which if Typhon was as bad as the story says he is, it's not a bad idea. You can see in the process he dropped his flute right there. But in order to escape, he essentially, this Pan decides he will jump into a river and turn into a fish. But he didn't quite get the job completely done, so he ended up being half goat and half fish, which is where the sea creature kind of thing, the depiction that you see in mythology is. And it's maybe, I don't know, I mean, I'm not what is it called? The people who study the origins of words, there's a name for that. Etymology or something like that. Anyway, there's some thought that the etymology of Pan was, or panic, the word panic was related to Pan's attempt to, flee this monster that's, so that was the original panic, was this fleeing of a monster. So anyway, that's the mythological story of the sea goat. Capricornus. As far as stuff that's in Capricorn, it doesn't really have a lot in it. So it's a relatively it has a few things, a couple notable deep sky objects, nice globular cluster there in 30 meter. Pretty nice, somewhat barred spiral, I guess you could say. I was actually had good intentions of looking up the type of galaxy this actually is. You know what the process is? I was going to look it up.
Barred spiral to me.
It does look pretty barred. It looks more like sort of rounded bars. Anyway, that's the UC69. So one of the more notable deep sky objects. And there's also a couple of exoplanets. A system with a couple of known exoplanets. It's 785 and NAB. And that's actually my segue into kind of the main conversation or the main thing I wanted to talk about tonight. So, anybody more to add about Capricorns? Anybody in here in Capricorn?
You have to be born in June. Is that what it
I
is?
think it is more in June. Okay, so the main thing I want to talk about tonight, and this is, I'm a little nervous about this because there's things that can go wrong with this. And so hopefully this will all go at least reasonably according to plan. I don't know if anything ever does. But what I want to talk about tonight actually follows from the meeting last November. So if any of you were in that meeting, I think the meeting was not here at the library. Actually, it was at I actually was not there. The guest speaker at that meeting was this guy, Rob Zone. Anybody remember Rob? He gave a presentation remotely. Rob's a astrophysicist and scientist with NASA at the NASA Goddard Space Flight Center. And he is interested in exoplanets and particularly in the characterization of their atmospheres, which is one of the kind of hot topics in observational astronomy right now. And he gave a presentation on part of this. And one of the things that Rob's pretty deeply, or Zone is pretty deeply involved in, is this thing called Exoplanet Watch. And Exoplanet Watch is a citizen science initiative funded by mostly by NASA in order to get citizen scientists, amateurs if you will, involved in the analysis of exoplanet observations of exoplanets. So these are a type of exoplanets called transiting exoplanets. Of course, the story on a transiting exoplanet is the planet passes in front of its star, basically. There's a tiny little eclipse that can be measured from the ground if you've got sensitive enough instruments, which it turns out is not all that hard to do. This is actually quite within the capability of relatively modest telescopes. And so this is what one of those light curves would kind of look like as the planet transits in front of its primary. And there's a lot of physical information that can be gotten about these. A lot of what's known about this is known because of the fact that as they transit across the face of that planet, there's observations that can be made about them. And of course, there's been some satellite missions that are designed to look for transiting exoplanets. So the Kepler telescope, I believe, the Kepler satellite was designed to do this, and then TESS, the follow-on from that, is also basically a space telescope for looking at transit. But here's why this Transit Watch program was started, and what kinds of things individuals can do, right? In order to get this kind of information about exoplanets, it takes a really just powerful observational ability, right? Because these are very dim things passing in front of very bright stars, very far away. So one of the things that's needed because of this, and because telescope time, particularly on orbital telescopes, is just simply super precious, right? To the point where on orbital systems it's allocated out sometimes almost with seconds. So if you want to observe an exoplanet transit and get some information, and again, like, for example, if you're interested in analyzing the atmosphere of one of these things, it has has to be actually in front of the star in order for this to work, because the light from the star has to come through, and you've got to separate out the bit of that light that actually passed through the atmosphere. And of course, that changes its composition, and from that you can infer what the composition of the atmosphere is, and actually maybe an avenue by which life will eventually be found all around exoplanets, right? It's chemical analysis of the atmosphere. But it takes extremely good timing on this. That you've got to know exactly when that planet is passing in front, because you can't just point the James Webb at something and wait for it. So, in order to facilitate this process, the ephemeris of the planet has to be known with pretty high precision, so that you know exactly when to point it at. An ephemeris, of course, is just a catalog of positions, basically, where predictions, including predictions of where this is going to be. So here's some ephemeri, I guess you could say, for a number of different exoplanets. So the exoplanet watch then is really about enlisting citizen scientists and amateur observers to calculate the ephemeris of these things. It's actually set up so that the tools are all available to you. It turns out even the data are all available to you, although you can certainly do your own data observations as well. And this is something I kind of have done a little bit of, so I thought I would devote this particular meeting to kind of walking through how this is done, with the idea that we might get some people in the club that are interested, and at some point we may even try to take some of our own data. So what I'm going to do now is I'm going to cut away here and go to the explain site. Actually, let me talk about one more thing before I do that here. As I said, there's a series of tools available for this. The main analysis tool is they call it Exotic. It's a software tool that we're going to look at here shortly. And you can also you can do your own observations, and there's certainly an active community of people that are doing this. But you can also get observations from Exoplanet Watch. So there's a couple of telescopes operating. These are on Mount Hopkins in Arizona. Right. This is the Mount Hopkins Micro Observatory, or MOMS. A couple of automated telescopes here, right? This automatically seek out a program list of targets every clear night, every night. And you can see they're fairly modest. This is not a large aperture by any means. And so the data I'm going to try to do here is comes from one of these, or we're going to get some data. We're going to get some data from one of these, from the archive of these MOMS telescopes, and then just kind of run through the process of analyzing it. So at that point, then I'm going to cut away from the slides and go to Transit Finder, the Exoplanet Watch homepage. So here's the Exoplanet Watch homepage, and there's a number of different resources here that you can look at. So you can kind of see there's a little bit of a background on what the Exoplanet Watch actually is. Kind of gives you a little bit more about what this exists for, what the purpose of it is. One of the things they've done a really nice job in my opinion, with Exoplanet Watch is they provide a lot of training material, a lot of background material. So really good videos on what all this is all about. There's good videos on training it and all that sort of thing. I don't think we'll take a look at one of those tonight, but if you are interested in this, it's well worth doing. And they kind of give a pretty good reason for doing all this stuff. You also see up here, there's a couple of there's a menu of choices. One of them is Exotic, and we'll come back to that one here in a bit. Okay, so again, what I want to try to do is get some data and actually analyze it and report it. So this takes us through the entire So, so to start, first of all, before you do this, you need to have already, if you're going to do it using their instruments, using their telescopes, you have to have a Google Drive account, which I think, as far as I know, gets set up automatically when you open a Gmail account, I think. Anyway, so if you decide you want to do some of this kind of stuff, you will need to get a Google Drive set up. I think I might just go ahead and log into my Google Drive just because it's useful. I found it's useful in some ways to have it open. So let's do that, and then I'm going to sign in, and I guess I've already signed in. So this is my Google Drive account, and this is the exotic folder, which is a folder I set up to hold this. And here's a list of targets that I've looked at already. So there's one on here I haven't looked at. Actually, this one, Lost 135, which is that's my backup plan in case we can't actually download any data. We'll go through that one as well. But so this is some of the ones I've already looked at here. Okay, so that's open. So let's go back over to Exoplanet Watch, and by the way, it also has this Slack, this discussion. We'll look at that as we go along here. Okay, so let's go ahead and get some data. And so we need to find that link again, check out for your data. And yeah. Alright, so all you gotta do to check out data is you have to enter an email address. So I'm actually, this is basically a little counterintuitive, but I'm actually gonna use my I'm gonna use my Gmail address. I'm gonna enter my Gmail address here. All right, and then I assure it that I'm an actual person. Click submit, and if things go according to plan, which when was the last time that actually happened, we should see on my drive a new data set pop up. And sometimes, this is why this is a little risky. Sometimes it happens pretty quickly, and sometimes it doesn't. So let's keep our fingers crossed here.
Okay. Does it show up with the shared with me?
I think it.
Earlier this week.
The last one I did was August 26th. That's my backup right there. So, and I think actually the first time I did this, I might have actually used my K-State account. The one thing about this that is a little bit tricky is that it only lets you download a data set every 2 days. I think, to keep you from just, and they give you a limited amount of time to actually do this. So you download, depending on where you look in their site, either 2 days or 2 weeks. What they do is if you haven't reported your results within a certain period of time, they release it back into the archive and somebody else can download it as well. So let's see here. I hope this is not going to fall apart right from the very beginning.
Do you get an email about it, or it just shows up?
You get an email
Okay.
about it. So let's go. Actually, that's a good suggestion. Let's go to Gmail. So there's the subscription confirmation.
Oh, at the top.
There it is. Okay, so now you see it says observation data checkout ready. So now we got data. So let's go and download this. So it says it will download it to Google Drive directly, and there's a lot of tools for doing this kind of thing. There's like Astro Image J and other things. So I just kind of use the Google Drive one. So there is our data. Notice it's in the form of a zip file. So if you look at this, it says MOMS. So it's coming from that micro observatory, right? Cecilia, as far as I can tell, is the name of the telescope. Apparently the telescopes have names, and Cecilia is one of them. I don't know what the other one is. But as far as I can tell, that's what that is. And then this is the star. This will point us toward the object, so it's around WASP 3. Right? Okay, so we got to unzip this. So I'm going to go do that. This is just a tool that runs in this.
So it's like an add-on for Google Drive.
This is an add-on. Yeah, you actually have to download this. Another way to do this is to download it if you've got unzipping tools on your computer. You can download it that way and unzip it and then upload it back. But it has to be the data has to be on Google Drive in order to use exotic way we're going to use it. Okay, so there's all of our files. I'm going to extract to the drive. And you notice there's quite a few of these files here.
Mm-hmm.
They're all zipped FITS files, which exotic can handle. It can directly handle either a FITS file or a zipped FITS file if it's zipped with the GZ zip tool. So there's a folder up there. You might have seen there's a folder up there that says darks. Right? These are dark images, just exactly the same as we would use in any other context. There's also a README file. You see it going by right there. Then that'll contain some information about the object itself. And I think it's always a good idea to look at that because there's important stuff in there that you need to know. So as soon as this is done, yes, lots of images. One other thing I might caution you with is there's no guarantee this is the data because this is a completely automated system, and I don't think any human being ever looks at these until one of us does. So I actually downloaded a data set, and it was like bed sheets, right? There was no information in there whatsoever. Crossing my fingers that we don't get that problem tonight. If we do, then I'll fall back on plan B, and we'll go back to a data set that I downloaded, I think. Okay, so it looks like we're all done with the zip, so we can view things in the thing. And one thing I found is that you need to, let's see, you need to change, it's a good idea, I think, to change the name of this file, right? So I'm going to go back here and I'm going to right click on that. Hang on, go back for just a second. So this is called WASP3, all right? Mom Cecilia WASP3. So I've just been, as my way of doing this, just changing the name to just that part of it. So Mom's Cecilia WASP3. Now I'm a little bit worried that I've already got a WASP3 file because I seem to remember having done a thing. So I'm going to go over here and just see. Yeah, I already got one. So I'm going to go back up here and make this one like WASP3. What this is probably WASP3 is the star, right? So probably this is a different exoplanet around the same star. Hopefully this won't cause too many problems. Okay, and then I'm going to move this into the exotic drive. So I go to organize, move, and I'm going to put it into the exotic because that's where the exotic software is going to look for it. And again, this is something that if you decide you want to do this, you're going to have to set this up ahead of time to have the file structure ready for this. Okay, so there's WASP 3 new right there. So we are ready to roll. Now comes the part that's going to be a little bit of a tricky thing. So the software that the Transit Watch group developed, actually Dr. Zellen was the major developer of it, is called Exotic, which apparently stands for Exoplanet Transit Interpretation Code. You know, that people have to make up words about things. This is a reasonably good one, I think. And if you go to the Exotic page on the Transit Search site, there's 3 different links you can follow. The first one is just the beginner tutorial. And if you want to do this, I would really strongly urge you to go through the tutorial because it kind of walks you through it. The one thing that the tutorial does that neither of the other one two does is it has a default data set, so you don't have to get your own data. It has a data set. It's actually a really good one because it produces a very distinctive looking link curve. You can't report it, right, because it's everybody else has reported it. But it's good just to learn the nuts and bolts of the software. But you won't be able to download data. You won't need to download data. Once you move on to using one of the other versions, you'll need to kind of go through the process of data download. Then there's what they call standard, which is what you would use if you're using the Exoplanet Watch telescopes. So if you're using those micro observatory telescopes, this is the one you want. That's the one I'm going to use. The advanced one is if you have your own data, if you've been collecting your own observations. This one I've not used yet. It's on my list of things to do, but one of the things I know about it is you have to have a significant amount of information on your own telescope. Right? You need to know, what its aperture is, some details about its camera, and all that sort of thing, because Exotic will need that information. There's yet another way to run this, which is to actually get the Exotic code. For that, you have to go to a GitHub site, a data distribution site, and it's Rob Zell's site, and download the code, and then you run it as a Python project. And that's the most flexible, but also probably the most difficult way of doing it. Haven't done that yet, but one of these days we'll get a little bit of data of our own. We'll probably want to analyze it that way. So I'm going to go. Question?
You probably do that on a Linux environment then too.
Actually, there's a Mac version, a Windows version, and a Linux version. So they cover the operating system basis. So let's go to Exotic Standard. And Exotic Standard, this it's Python, but it's a Jupyter notebook, which is a type of Python. It's a Python form that you don't actually have to have Python on your computer in order to use it. It runs in your browser, and it breaks up processes into a series of sub-processes. So the sub-process here, you can see step 1 is to mount the Google Drive and load Exotic. This is the one that's the biggest problem, to be honest with you. And so I'm going to go ahead and get this started because it can take a long time for this to work. I hope it doesn't, but chances are it will. So, at some point, if anybody needs a break, now might not be a bad time, but let's go ahead and get this started. So, first step is to mount Google Drive and load Exotic. So we're going to go up here and run this farm. I'll ask you a couple questions. It says the notebook was, since it's trying to get to Google Drive sends a alert to you and says, this is not ours, or you want to run it. The answer to that is run it anyway. And then you want to connect to a Google Drive, and the answer is yes. Okay, so I'm going to connect to my account since that's where the data are. And let's see, let's do that and continue. Okay, so now here's what has typically happened to me in the past. It says that it may take a few minutes for this to work. What often happens is it sits there and twirls and twirls and twirls, and then it fails the first time. It almost inevitably So like I said, now might not be a bad time if anybody feels like they need to take a little break or something, because it may take a few minutes, like 5 to 10 minutes for this to finally work itself out. But what it's trying to do is load some, it's trying from the Google Drive of the project Google Drive, it's trying to load some tools. The other thing I thought I would do, since I think we'll probably have a little time here, is I wanted to go back and show you that that Slack, because this is a really good resource to have access to. So if you go to, we'll go back to the overview page here, and go to this Slack. And I don't know, Slacks I guess are just, they're like information pages, I guess. How would you describe this?
Kind of chats.
Chats, yeah. So if you go, so I'm going to open it in the browser. So here's the Slack. This is me. So there's my little area, and you can see some of the people on there. This is Rob Zone, the guy that. But what you kind of look for here a lot of times is just posts from people. Like here's a post from somebody who watched a video of some kind. Problems with data requests. You see this a lot too, because this data requesting system is, it has its good days and bad days. So sometimes it doesn't necessarily work very well. Here's a guy who is reporting that this particular zip file has unusable files in it. So he's trying to, inform the Exoplanet Watch people and everyone else. And so post that. Rob says so they're just trying to figure out what's going on here. This is information on how to upload things, which things what we're going to be able to do here. I hope sometime before 9 o'clock and so on. So this is a really valuable resource. I look at it every couple of days just to see what people are up to. And there's a group of people who are here's introductions for beginners. So if you join the Slack, say hello, and usually a lot of other people say hello to you, and so on. Okay, so let's see if we've made any progress on that thing, and it turns out we have not. Again, this is not unusual. It usually takes a long time to fail the first time, and then the second time it works after a while. So again, if you guys want to, take a break, talk about something else, discuss things, ask questions in the bathroom, this would be a good time.
This is a common, everyone has this delay.
As far as I know, I've asked questions about it, and everybody's like, yeah, right. Tell us what we don't already know. So you can kind of see here, this is, again, very typical. This bokeh is like a graphics tool. It's one of the tools that this Exotic program uses to input and output, and then it also crafting tools. So it's basically just a library that it needs. And then Exotic is the program itself, and then you can say your session crashed. Okay, this is completely normal. Irritating, but completely normal. So if you really want to know what happened, you can look at the logs. I don't really know if there's a point to that. So I'm going to close it up and run the code again. And if we are lucky, it'll work this time. If we're not lucky, it won't. And unfortunately, this is a step you cannot get around. So even if you decide to go to Plan B and use the data that I downloaded the other day, you still got to get past this step in order for this to work. So again, if there's questions or anybody comments, now's a good time. It does give you a little time lapse down here in the corner. Notice it's running Python, right? So it gives you a little time lapse down there, so you know exactly how many minutes it takes to fail or not
download the software, forget that we got around this.
As far as I know, this would not be an issue with, if you download the software for yourself. Again, I have not, okay, here we go. So now we've got Bokeh or Bokeh, we've got Exotic, the software itself, we've got the NASA Exoplanet Archive, AstroPi, which is a set of Python tools that deal with astronomical things, and some utilities. This is usually a good sign because usually when we get to this point, we're going to get to the finish line. Let's cross our fingers. Say a prayer to the gods. Okay, so now we've loaded MATLAB and SciPy and some Google utilities, and we got all the tools we need. So now we're ready to work. Okay, so next thing we need to do is actually load the images. And one thing I should point out here is if you click on this, it will now, once you have completed this step, you can see your own Google Drive, right? If you click that thing, it looks like a folder right here, this little guy right here. It'll show you that. And so I'm going to go to Drive, and then My Drive, and then Exotic, and then you should see there's the data set we're working on, right? Cecilia lost 3 million. That's the data set we're going to look at. So first thing we have to do here in this little box is we've got to tell it which data we want. Notice that it gives you Exotic as its default path, right? So that's the reason why I moved the data set into the Exotic drive, because it just works a lot better. You can get around that if you want to, but it just works out a lot better if you do it this way. So let's go ahead and enter the file that we want. So it's so that's all caps, 3.
It's lowercase.
Oh, what did I do wrong?
Yours, I mean,
News in lowercase, right?
yours in lowercase.
Right. So,
Oh, and WASP is in, the ASP is in lowercase.
oh, good catch. I normally do these things in caps. So good catch. Okay, and then the other thing that you can do here is if you're planning on reporting your observations and you belong to AAPSO, right, the American Association of Variable Star Observers, they're the ones that archive this, for the most part, are archiving this data. And so if you want to get credit for doing this, like, there are people doing this that have been included in publications, and their names are in papers and stuff. So if you want to be credited for this, you need to enter your observer code here. So mine is GBOC. If you don't have one, and you can still upload, right? Even if you don't belong to AAPSO, you can still upload. But I mean, if you're interested in this kind of stuff, AAPSO's $100 a year or something like that. It's not terribly expensive to join, and it has a lot of resources that are very useful. So. Okay, so we are set up here. We'll go ahead and run this cell, and it's going to do a couple things. Oh, dang, I should have done something. Uh-oh. Problem. Okay. Shoot. I've had this happen before. Oh, shoot. I forgot to do something. Never mind. This is my fault. Not that it would be anybody else's, but I have set this wrong. You also have to enter the object name in order for this to work. So I skipped a step here. Remember that the object name is the exoplanet, not the star. So in order to figure out what that is, I'm going to go back over to my Google Drive. I'm going to go into my Exotic folder. I'm going to open this up. I'm going to find that README file.
That's the wrong folder.
Which one is it?
New.
Oh, that's the output folder, yeah. It creates that when you start the process. That's where your data will end. That's where your results will end up. So I'm going to go to this README file here, and that'll get information on what we're actually looking for. So the object in this case is WASP-3b, so it's actually an exoplanet that I've reported data on before. This is probably from a gives you a little bit of information about what the conditions were. They rate their weather on a 0 to 100 scale, and this particular day was 59.65, so probably not super good conditions. I had one the other day that was like 96 or something like that, so that was a pretty good night. Yeah, and again, just some basic information. The one thing that you're actually going to need here is this object designated, this object name. So I'm going to go back to the program, and we're going to enter that here. So that is WASP-3B, and hopefully this time it'll get it right. Oh crap! Tell me how to start this up again. Okay, so we're going to reset the runtime.
If it reset at the runtime, you might need to run
My-
Thomas again.
Yeah, shoot. Okay, sorry
But
about that.
it might be probably be faster next time.
Yeah, that's right. I'm gonna have to go back and. Okay. So I'm gonna exit the page and stop this run. And I'm gonna go back up here because we're gonna have to redo this part again. I'm sorry about that, guys. It's we're gonna go back to this step. So let's go back and redo this one. Again, this has a lot of the characteristics of kind of roll your own, the error trapping and stuff. Of course, I shouldn't blame the software because I screwed up. Hopefully it won't take quite so long.
Open software, decent software, catches you, you screw up with correction.
Yeah, well, this is definitely
Works around you.
this is definitely not commercial grade software, and like I said, this is an operator error. No, this is not from the software.
When it's complete, does it generate like a scatter plot of the light curve then?
Yes, it's going to generate a light curve, and it's going to generate an ephemeris, and that's what goes to AVSO. And so there's actually a tool. There we go. So there's actually a tool, which again, not here we'll get to, that will help us with that. Okay, so we got the path, we got the Google path, we got the observer code, and we got the objects. I'm going to go ahead and run that. And kind of luck. Okay, so it says it's downloading the telescope images, 118 images, that's a lot. And it's also downloading information about the planet itself, right? So this is why it had to suck in that information from the next exoplanet. And, it's kind of, for me anyway, it's sort of worth taking a look at this, just because it gives you a little bit more idea about what you're actually doing here, right? So, some of the things I think are kind of interesting to look at here are the star type. So, 6400 kelvins, so that would make it like a G-type star, I guess, like similar to the sun, I guess. The ratio of the planet to the stellar ratio is pretty big. So this is probably like a gas giant or something. It's a big planet. It's actually pretty close. Its orbital period is only 1.84 days. It's only taken that long to get around its star. So this is probably like a hot Jupiter kind of exoplanet, right? Really close to the sun, to its star. The star, one of the things I think is interesting is the metallicity of the star itself. It's the ratio of iron over hydrogen. And that tells you a little bit about how old the star is. This was 0, it's balanced out. It's actually the log of iron So if it's more hydrogen, if that's a negative number, that means more hydrogen means probably a lighter star, right? More hydrogen star is going to be a younger star. So it's just kind of interesting, I think, to sort of look a little bit about what you're doing here. You actually want to look up the planet. You can if you just search. Actually, if you just do a general search, what you'll often get is the NASA exoplanet archive, and you can take a look. Actually, you can take a look at it. What it is. So it's a gas giant. Actually, an F-type. About 2.5 times the size of Jupiter, really close to the Sun. 0.0315 AU, so really, really close. Okay, so let's go back to task here and carry on. Okay, so the next step is one that is not, it's not necessary, it's not strictly necessary, it's listed as optional. Strongly urge you to do it. This is one where I kind of messed up one time because I got bad data and I said, oh, I'm going to skip this step and move on. And then you get to this step down here, you couldn't do anything because there was no data there, right? So if you look at the data, you consider yourself that embarrassing waste of time. So what this will do is it loads all of those images. Again, this takes a while, especially with a one like with 118 frames like the one we're looking at here. Notice also that what they say here, report if there's issues, report them on the Slack channel, right? That was, we saw that earlier, right? Somebody had reported a data set as not being usable. So that doing that just kind of helps the people that are doing all their organizing all this to make sure their data quality is up to snuff. So we will hopefully at some point come up with an answer here. I hope we can get this done in time. So I'm going to keep you guys.
It says 1 second for each image, so this will take 2 minutes.
It's about 2 minutes. Yeah. I probably should have just skipped Capricorn and I'm going to switch this. Just like that. Mix things up a little bit. Okay, so
What I tried to do the other day, trying to organize my medications in the morning, and I had 4 files I wanted to download. So I said, well, with those download, I will organize my. My internet was so fast, I didn't get the organizers over before. That's what you need.
so here we go. It looks to me like we're going to have to do a lot of cleaning on this probably because it was cloudy that night. I would imagine that would be the reason for the poor image quality. So we got 118 of these. If I look through these, I would say so far not bad. You don't want to throw away too many of them because you won't get a good one. These, let's get rid of. So let's get those guys out of there. Let's get these guys out of here. I don't know. What do you think?
Remove.
You want to remove it? Terminate it with extreme prejudice.
You're trying to get it down to a few percent of,
Well, it's kind of a balancing act, right?
one package.
Yeah.
Where's the star?
Well,
Yes,
we're
right.
coming to that actually. That's the.
If we knew, we could know a little bit. Some of the clouds are.
And you can look it up. In fact, that's the next thing we're going to have to do is figure out where the star is. I'm going to keep that one. The thing else, the balancing act here is that you want to have enough images to get a good curve, right? I'm going to get rid of these guys. No, I think that unfortunately we can't just go back and say, please send us another one. At least I can't for another couple of days. But we'll still get something out of it, I think. And as they, as when I've sat in on webinars for all this, they always say, report your data no matter what, so. Maybe pretty bad. This one's bad. That one's pretty bad. I don't know, what do you think of that one? Not great. unfortunately, that's just kind of, kind of the mock flops. And then finally we get to nothing images. I had an entire data set that was this, and it really
Yeah. How did that happen?
completely baffled the crap out of me until I figured out, until I looked at the data and thought, oh, no wonder. So yeah. Okay, so we're all done. If you go back, which I'm not going to do, and look at the folder again, there will now be another file that says bad images, and everything we took out is going to be in there. So if you want to go back and look at your bad images, that's the time. Okay, so now we're going to get to the meat of the problem here, which is that we're going to have to identify the star and comparison stars. This is something you always have to do when you do any kind of photometric stuff, right? So the telescope, this is from the Micro Observatory. What this tells us is a bunch of information about that telescope that we're going to use. This is nice because you don't have to enter yourself. The exoplanet watch group also has a 0.4 meter telescope that they use for this kind of thing. If you happen to get a data set that comes from it, you got to switch this. But we have mobs, right? That mobs thing in there that means that we're here, so we can take that. And then we want to enter the star here. And notice that we need the star and not the exoplanet itself. So the star was WASP-3. And what that's going to do is it's going to generate a star chart that we're going to use to identify which star this actually is. So I'm going to go ahead and run that guy. And so there's an image, and there's our star chart. Now, here's one of the things I seriously don't like about this. The star we're actually going to be looking for is marked by the cross right there. Everybody see that? This is really small, and it makes it really, because, my eyes are not as good as they once were. One thing that you can do, if you want, is you can go to AAVSO and generate a bigger version of that same star chart if you want to. So that guy was WASP-3B, right? So if we just come down here and say WASP-3B and create a finder chart, it should create exactly the same thing we're looking at, just bigger and easier to look at. Oh, sorry.
WASP-3.
It's got to be it's got to be V0838 here.
Oh.
V0838. So should find it. Okay, so it's a little easier to see. The problem, of course, is that you then don't have them side by side with each other. But so this, there it is right there. You notice also these numbered stars around them. Those are AAVSO comparison stars. So those are the things that we're going to want to be comparing it with. So let's go back to the thing, and now we got to find where we are. This is a little bit like anybody who's ever run the Tombaugh, when you do the syncing. This is a little bit like that. You got to look for a pattern that is similar here to over there. And taking into account the fact, so this group of stars right here is here, right? So they don't match each other exactly. So what do you say about fingers? So it'd be, let's see, right there.
That's what I was thinking.
Yeah. So one thing you could do is you can zoom in on that. So if you go to this little tool right here, and then zoom in on it. Yeah. So it's this one right here, right? Notice by the way that it's kind of right next to another one, which is inconvenient, but that's okay. All right, so here what we need to do is we need to enter the coordinates of this star, and then we're going to pick some comparison stars. So I'm going to put the crosshair on here and try to get it as centered as I can. And then see where it says inner coordinates or the target started on there, we're going to enter those coordinates. Now, they have to be integers. You can't use decimals. So I'm going to use, 61 and 242?
Mhm.
Agree with that? So, and they have to be in brackets. So 61, 242. And then I'm going to press return. And now we want to enter two comparisons. So
Mhm.
I typically think the best practice is to pick the comparison stars that are as close as possible to the one you're working at with and as similar in size, right? Because you want them to really be comparisons. So if we look at this, 121 is right there, and that is this one.
Mhm.
So let's get that. Anybody by any chance have a pen and paper we can jot this down?
So are you just regarding color information in this one?
Yes, we are. Yep. This is not, because these are all shot through clear filters. That's a really good point though. If you were doing this through sometimes exoplanet stuff, they use a V filter, right? And if that's the case, then we would have to think a little bit more carefully about what we use comparison stars on, because
And plus the fact you've got a long length of observation run, and so you're gonna have varying air mass problems and color differentiation.
yeah, the air mass calculation is built into Exotic, so it's doing that for you, which is very nice. But okay, so this one is 38, 256, we'll say. And then let's see, what would be another good one to use here? What do you think? So we used 111 might not be a bad choice. That one's going to be this one. Is that right? 111.
Mm. Yeah.
Okay, so we'll go over here to 111. And center it as best we can. And jot these coordinates down, so 128, 258, I guess. Okay, so now we're going to enter those in here. You have to enter them in this particular format. So in this case, it's going to have to be bracket, bracket. First set, so 38, 256, bracket, comma, bracket, 128, 258, bracket. Okay, so we should have then all the information that we need. So now we go to the fourth and final step, which is generating the light curve. It says it can take between 5 and 60 minutes in order to do that. I have never actually seen it take 60 minutes, but I certainly hope so. If it does, I'll show you what the results look like from the previous run. You can also enter your name here, and it's a little cheesy, I think, but it generates a little certificate for you. So, you know, it's a nice spot. Okay, so now it's going to go do its thing. So again, we might just sort of think about what's going on here. So, there's somebody's pen.
Mine.
Thank you. All right, so this is gonna, like I said, gonna take a little while to do. Like I probably should have started this without talking about installation.
So have you experimented with using type
that would be worth doing. The one thing I would wonder about is what the format of the results are, because I think the ASO looks for the output in a particular format. And so if one were to try using it, but they
Generate guys to hear it.
yeah. The people that do this, the people that are running this program, they're not dictating software. They say if you want to use a lot of people that use Astro Image J, there's typically a discussion going on in the Slack about using Astro Image J. I don't think I've ever seen anybody discussing using Tycho, but I don't see why not.
This seems like it might be a little more automated than the steps that you're going through there.
Yeah, it might very well be, actually.
If you download images and keep them in your system and use Tycho, and not mess with Google, the interface back and forth.
I think what the motivation for this was, they wanted to maybe capture people that don't necessarily reduce data. So it's made to be kind of as transparent to the users. Yeah.
They don't know. Tiger Tracker wants to have a GPU and stuff, right, too. So,
I'm amazed how fast it is on my Mac. I haven't tried it on my MacBook. This is unfortunate, it's so faster. But, I've got a real fast PC, and that Mac's faster than the PC. Not that either of them are very fast when you're doing it.
I think I'm surprised it's faster, but I think the Macs have some type of machine learning cores in them on their CPUs.
I am kind of anxious at some point to use the standalone version of it, and also at some point, if we ever are able to collect in some data, some original observations. Actually, if time permits, actually maybe let's go ahead and just look at one thing while this is going. If you decide you want to do your own data, of course the question is, what do you point at? There is a website called Transit Finder, which is actually at Swarthmore College in Pennsylvania, I think, and it will find observation sites for you. So this was already set up actually for Farpoint. If you get it originally, there'll be a pull-down menu here with a bunch of observatories, and then at the bottom it has specific latitude and longitude if your observatory is not listed, which by Farpoint wouldn't be as but anyway, so this is the latitude and longitude of Farpoint. We're on U.S. Central Time. This is going to show us transits for the next 3 days. A few other things about it with the positioning and stuff of it, so a little more information. But you get some net on this. And this is, I believe, going to be transits in the. This is from tests. These are transits from the test thing. So it tells you what the start and end times are. So this one is, and these are UTC times. So this is an hour and 11-minute transit. What this little thing shows you is that part of it's in light for us. So this is before the sunset, basically. There's a thing over here that kind of tells you what the priority is, I guess. There should be a column that shows you what the priority is. It gives a numerical score for how important something But you can go through here and find, like, you know, potential, potential transits to look at. So this is kind of a, probably kind of a useful tool. Let's see. We're still grinding away. And again, there's a lot going on here that's pretty automated, that if you were wanting to kind of get into the weeds a little bit more on this, or if you wanted to maybe make a little bit more precise observation, you can set some of the things yourself. So, you know, it's figuring out that the sky angles is how big the little circle around the comparison star is, and there's a whole kind of procedure for figuring that out. Yeah.
It's all complicated.
Yeah. Well, this is, and again, you know, these are the kinds of things that, if you're really interested in this sort of thing, one of the things that was really helpful for me was ABSO actually, it has these classes they have these classes you can take, and they have one on exoplanets that is actually taught by the lead, the sort of ABSO section head for exoplanets, and you know, it's this super experienced person that's done tons of this kind of stuff, and they sort of walk you through using astro imagery, how to do a lot of this kind of stuff. And even if you don't use astro imagery, it's a really handy thing because it talks about the, you know, the nuts and bolts of things like selecting apertures and selecting comparison stars and all that sort of thing. Actually, you know, what else I can do here is show you.
You use any black waters to help us at all over the years.
I haven't recently. I used version 10 at one point in time. And
Exactly.
it was pretty honky.
Yeah, he's out of astronomy now. Getting rid of his scopes. But he's still doing that.
So the software,
He's at 12, it's free.
yeah.
At 12, I think the interface is worse than all the theater versions.
Well, it's more complicated. You got more steps going on.
Well, we just keep getting to it.
So here's what the output, this is not the output, this is actually the same planet, star planet, but a different time. This is what the output will actually look like. You'll get the light curve, and you'll get a file, an ephemeris file. So the light curve, in this case, look like that, and again, you can only, you know, basically got about half of it, right? So, you know, it would go down and then back up. And then the ABSO report text file is here, so this is the information that actually goes to ABSO, and you can see all the various information. So there's the observatory code, there's a mock observation, there's my code, and then the ephemeris itself, right, the position of all these across the transit, which is this information right here. That's what it's calculated. So eventually there will be, and I'll just go ahead and show this bit too while this is cranking away. There will be a set of instructions, you can find a set of instructions for how to actually report your observation. So let's see, let's go to, let's see. Submit your observations, and there's a little video about how to actually do that. So if you go to the ABSO website, it will exoplanets.
Finished.
Oh, they finished? Okay, good. We'll be able to actually do this then. So, let's go ahead and submit our observation then. So we will go, macro observatory is correct, macro observatory is correct. So we'll choose a file. Actually, we're gonna have to download this. Unless there's a way to actually get into the Google Drive, we're gonna have to download it. So let's go back to Google Drive. So I'm going to download the whole output file, which is this folder right here. This is what we just created. So if we come over here and click download, it's going to zip that file up. Download it for us. I think. Okay, so now it's ready to go. So we can.
It downloaded already.
Yeah, so it should have come to the downloads folder on the
Mm-hmm.
host. I'm still kind of getting used to this laptop. So,
Mm-hmm.
so we'll go to downloads. There it is. I'm gonna move it into my. I'm gonna move it into the folder that I've been doing this stuff in. Actually, I'm just gonna put it on the desktop. Actually, I'm just gonna leave it where it is. So let's not worry about that. Let's go back to the site.
Do you need to extract it? Or?
Yeah, we need to extract it. So let's go. I think we need to extract it.
Mm-hmm. You pick the report file, not the zip file.
Right. So let's go back to.
Sorry.
Yeah. So,
There.
right. So let's go here and then. Guess we can just put it back where it is, and let's give it a name here. So we'll just call it the same thing we called it. Actually, what I've been typically doing is giving it a date because you know there's more than one of these. But I don't know. At this point, I'm just gonna or something like that because. Okay, so now we have. Should have lost right? Okay, there's our curve. We can take a look at it if we want. So there's our light curve. Looks like the other half. That we have. There's our. There's our ephemeris. So let's go back to the ASO and choose the report form. That's the ephemeris. So it should be in the download folder. Oh crap, that's the wrong one.
Yeah.
So this should be the ADSO version. And then we'll choose, I'm not sure which one, I'm never sure which one to send. I've been sending the PNG file. That's the light curve.
Mm.
You have to accept their GDPR. That's basically a thing about privacy of personal information, which you know is a big thing these days. And then we submit.
Need the. Oh, you don't have to put in that stuff.
Which stuff?
Site and.
Oh, those. Yeah, those are already in. But site is Micro Observatory, equipment is Micro, so it knows how to interpret that.
Cool.
So now, if we go into, you know, the AESO exoplanets, and there it is, on the bottom. Right here, it says 20, so that's today. Oh, wait a minute, it hasn't shown up yet. It may just take a little while for it to show up, but see some of the previous.
Well, the observation date was 2016 from the
Yeah,
data.
that's probably what it is then. So anyway,
Okay.
so if you have a cloudy night or a couple hours on your hand and you want to look at some data, this is a pretty good way of doing it. What I want to do next, as far as kind of next steps, I guess, I would like to do some original observations one of these days. And it wouldn't necessarily take, even the, we're looking at really small telescopes and light years, so something like the Tomahawk would certainly be useful, but might be, bigger hammer than is actually needed for a lot of this. But this could be an example of something that might be possible on where there's too much room to do NEOS or something like that. So that's one potential next step. Other possibilities. Here's one other thing I wanted to point out. If this stuff seems interesting to you, there is a webinar, one of the AVSO webinars coming up next Saturday. Not the day after tomorrow, but the Saturday after that, where they're going to talk about other opportunities with TESS exoplanet discovery. So you can actually work with TESS data to find new transits and things like that. So this Karen Collins will be talking about that. So if you got a spare time on Saturday and you want to take a look at that. Again, you don't have to get any AVSO to analysis. Okay, that's it. Questions, comments, anything?
What was the magnitude variation here that you
It was about
earmarked? Yeah.
It was about 0.02%.
0.02.
Yeah. So
That's pretty respectable.
yeah, it's a pretty,
Considering that it's got
yeah, and it's a pretty big planet too. So off the magnitude that's far. If you're looking at some of the really tiny little Earth-sized planets,
that's gonna make it.
yeah,
Then you're gonna have to get down to
something. Yeah. But,
Maybe this is the way to get my brother away from his galaxies.
well, it is a little weedy. There's things that you kind of have to know, and all, but why not?
Cool.
He's wanting to do the videos, but he hasn't got the patience.
That does take that.
anymore because everything is listed now, 21.5.
Yeah. It is kind of another thing that one of these days when we get the time of it, that would be a little better. But this stuff like this might be another option for advice when we just can't get anything done. And the equipment that a lot of people are using to do this stuff is pretty modest. The guy that's his name is Conti.
Yeah.
Dennis. He's the one that's the AVSO's kind of exoplanet section leader and organizes a lot of teaches the class. I mean, his telescope is very modest. I don't even think he has a permanent observatory. He's sensitive goes. So this doesn't necessarily require.
Some of it has to do with your sky conditions, where your sky conditions normally are good or, moderate versus, every night for about 5 nights is pretty trashy and then you get one cleared out.
Well, that is so you have to be on the target for probably minimum of an hour and a half, and in some cases more like 4 or 5 hours.
Well, this would be picked up and you only got half of that. That
So, you know, staying on something for 4 or 5 hours means you gotta probably have some guiding and capability to guide. And you're kind of assuming the night's gonna stay reasonable.
But Soco does have, was it a 5-inch tractor on it that has a guide camera on it. It's kind of tricky to use sometimes. I found that if you go in and set up the guide camera first before you set up the 600, it will find it easier that way. Sometimes that's trouble finding it if you got the 600 rolling already.
Yeah.
So do the guide camera first, set that up first, and then go back and do your
Yeah.
600.
I think when we looked at I guess this is not the,
We were gonna use it,
but,
not on 400 millimeters, guide camera. One was a CW camera. PHC2, haven't touched it yet. You don't need it.
Well, and that's fine, I mean, but you're talking about 4 hours, you not need it for 4 hours.
Well,
If you're gonna stay at one star on
you
spot,
do an auto swim to it. If it drifts,
Oh, just played solve and slew again.
yeah, that just takes 2 minutes.
yeah.
And
also the apparent magnitude of this star that we were looking at is 10.454. You know, that's way brighter than a lot of the things that we've been looking at. So it might be possible to do this on some nights that are not either transparent enough or too bright to look at the neon.
Yeah.
Provided you stay away from the moon. In fact, the transit search tool will actually warn you if you're
Yeah, so it's not so bad, if you've got a dull night, it's not really working very well. As long as it's consistent throughout that night, then you can work with brighter stars and still come out okay. The problem is that shifting of atmospheric conditions.
Even if your comparison stars are right next to it.
Yeah, even then, and the reason why is the color shift, that thing we were talking about. When you go over a long period of time, you're gonna go up and down on the atmospheric amount of atmosphere you're going through. So that's gonna shift the reds and the blue differently. So now you got a problem with that.
they didn't get the refractive index isn't the same.
Right.
and the angle changes. So that,
Yeah.
you'll get and again the transit search site will tell you what the ingress and egress angle is, and also the elevation. So yeah, if you're really low on toward the horizon,
Yeah.
that can be too.
It gives a little message.
So at some point, again, one of my plans is probably on hold for a while until basically not working anymore. Is to, is to use my need to do some of this kind of stuff. And it can be done with pretty modest equipment. Other questions? We are about out of time.
Beep. Take your kid. Call if you're a kid. They're about to go.
Well, thank you all for coming. And,
That's all I need is something else to.
It is 8:45 and the library will close in 15 minutes. Please finish all printing and copying now. Children who need to call